8th grade lesson 10.2 is algebraic representations of dilations. So we looked at dilations as one of the transformations, enlarging or reducing, and this lesson just shows you can do that dilation algebraically. Pretty easy too, because all you do is you multiply both your coordinates, the x and y coordinate, by the scale factor, and that will give you the new points. That's the easy part. The difficult part is that it is time consuming. It does take time to do each point, each vertices of the shape, find out what the coordinates are, multiply them by whatever I need to do, and then get the new coordinates and mark it, and do that over and over again for each vertices. So that's the only difficult part. If you are multiplying by a whole number, you're going to get an enlargement. If you are multiplying by a fraction, you're going to get a reduction. It's going to make it smaller. So let's have a look. All right, we have this shape. This has a center, the origin as its center of dilation. So we'll see this grow out like you're pinching outward on the on your iPad or whatever. You can find points on the dilated image by multiplying the x and y coordinate of the original figure by the scale factor. So in this case, we have a scale factor of 3. So we're going to make it 3 times larger. And if it's going to be 3 times larger, then we multiply both the x and the y coordinate for each vertices by 3. And they started me off with my first set of coordinates, 2 on the x, 2 on the y, right there. So I'm going to make my way around from there clockwise. So my next vertices is over here. That is 2 on the x, negative 1 on the y. Then I have this one here. That is 1 on the x, negative 1 on the y. Then this one is 1 on the x, negative 2 on the y. This one over here is negative 2 on the x, negative 2 on the y. Up next vertices is over here, negative 2 on the x, 1 on the y. Then I've got this vertices. This is at negative 1, positive 1. And finally, this vertices, that's negative 1 and positive 2. Okay. Now I will take each of these, multiply them by 3. 2 times 3, I'm going to change colors here. So 2 times 3 is 6, and negative 1 times 3 is negative 3. 1 times 3 is 3, and negative 1 times 3 is negative 3. 1 times 3 is 3, and negative 2 times 3 is negative 6. Negative 2 times 3 is negative 6. Negative 2 times 3 is negative 6. Negative 2 times 3 is negative 6, and 3 times 1 is 3. Negative 1 times 3 is negative 3, and 1 times 3 is 3. And finally, negative 1 times 3 is negative 3, and 2 times 3 is 6. Now I will go through and plot all of these points. 6 on the x and negative 3 on the y is there. Oh, I forgot this guy. This was 6 on the x, 6 on the y, 6 on the x, 6 on the y. Done, done. 3 on the x, negative 6 on the y, 3 on the x, and negative 6 on the y is there. Negative 6 on the x, negative 6 on the y, negative 6 on the x, negative 6 on the y. I feel like I missed one. I missed this guy that would go right. Oh yeah, I marked that I did 3, negative 3, but I didn't do 3, negative 3. So 3 on the x, negative 3 on the y there. There we go. Now I'm at negative 6 on the x turn, and then go negative 3 on the y. Oh, I did that. That's a positive 3. Negative 6 on the x, turn and go positive 3 on the y. Negative 3 on the x, turn, go positive 3 on the y. And finally, negative 3 on the x, turn and go positive 6 on the y. And then I just go and connect those dots. And there is my, pretend that's all straight, there is my 3-time enlarged scale factor of 3. This one shows a reduction. It's reduced by half, so we know it's going to be smaller by half. And you still do multiplication, you're just multiplying by the fraction. So we are going to do the same set of steps. We're going to find all of our vertices, this point, this point, this point, this one, this one, this one, and this one. And then we will calculate them. So I'm going to go ahead and pause this and find all the vertices and put the coordinates here. Okay, I started here at 0, 5, 4 on the x, 2 on the y, 2 on the x, 2 on the y, 2 on the x, negative 4 on the y, negative 2 on the x, negative 4 on the y, negative 2 on the x, 2 on the y, negative 4 on the x, 2 on the y. Now I'm going to take these through and calculate them, cutting them in half. So I have 0 on the x, 0, 1/2 times 0 is still 0, and 1/2 times 5 is 2.5, right? Half of 5 is 2.5. Half of 4 is 2, half of 2 is 1. Half of 2 is 1, half of 2 is 1. Half of 2 is 1, half of negative 4 is negative 2. Half of negative 2 is negative 1, half of negative 4 is negative 2. Half of negative 2 is negative 1, half of 2 is 1. Half of negative 4 is negative 2, half of 2 is 1. And now I will go in and plot those points. 0 on the x, 2.5 on the y, 2 on the x, 1 on the y, 1 on the x, 1 on the y, 1 on the x, negative 2 on the y, negative 1 on the x, negative 2 on the y, negative 1 on the x, 1 on the y, and negative 2 on the x, 1 on the y. I will connect those dots. And there I have a half-size reduction of my pre-image. So that's how you do the reduction dilations. You just multiply, just like you did for the enlargement. Just multiply both coordinates by the scale factor. It's being multiplied by a fraction, which we know now will make it smaller. Now those previous ones showed where the origin was in the middle of my image, or my pre-image I should say, and so it just enlarged or reduced around that origin. So the question might be, what if the origin isn't in the pre-image at all? What if it isn't in there? What will happen? So if I have a scale factor of 3 on this example for ABC, I want to enlarge it because I'm multiplying by a whole number. So you would still do the calculations. You do everything the same way. You're still going to multiply your xy coordinates. Find your xy coordinates, which they did for you. Multiply both x and y by 3, which they did. You get your new set of coordinates and you graph them, and you're going to get your enlargement. But notice the only difference between when the origin was within the shapes on those previous two is the origin stayed the center. In this case, you see your enlargement ends up moving. And remember, we talked about center of dilation in the previous lesson. Like if you connected these down, C to C, then you'd have this thing going on. So that origin ends up being still your center of dilation. It's just that you're dilating outward. So that is how you handle those. It's just the same scenario. So really the whole thing is find your vertices, your coordinates, multiply by the scale factor. You'll know it's going to be larger if it's multiplying by a whole number. You'll know it's going to be smaller if it's going to be multiplied by a fraction. And then graph the new coordinates and you're done.